So in this segment, we are going to, we have already learned how to identify basic angles and also angles in the respective quadrants, and each of the quadrant give us certain things. And I know some of you may have already learned what's ASTC, but I think why we want to learn ASTC is very important, because after we identify the angles, we want to be able to state the ratios of the angles, so the trigonometric ratios of the angles in their respective quadrants. And before I even start on this again, we're just gonna use this blank space over here on your notes, or if you have anywhere you can do it. I'm gonna just draw an axis to make it kind of like what we usually do actually. So we have the y-axis and we have the x-axis over here. Now let's say I have a point on the first quadrant first. Okay, so let's label the point here. Let's call this point P. Okay, maybe I'll zoom in a little bit. Okay, point P with the coordinates x and y. Just give it x and y, right? And we can make a line, a reference line, right? Okay, so let me just make this reference line a little bit bigger. Okay, so with this reference line, okay, and we know that we can actually do up a right angle triangle from here downwards. Okay, so just gonna do this right angle, this make it dotted line, and we know that for this right angle triangle over here, okay, we have the bottom length, which is actually just the horizontal distance, right? So this, in fact, from here to here is just in fact x distance, and here to here is in fact just y distance. And from here, okay, based on trigonometric ratio, and we kind of like, and let's give the length of OP as r. Okay, just let it be r. And we know that by trigonometry ratio, okay, this is something that we have done previously, we can figure out what is let's have the angle here. Angle here is theta. Let's make this theta. Okay, let's call this the theta 1 or even the basic angle, because the basic angle in the first quadrant is just this. Okay, we can say that cosine of theta 1 is simply equals to the adjacent over the hypotenuse, which is just simply x over r. Okay, and we can also say cosine theta, not cosine, sine theta 1. Sine theta 1, the 1 means is just a reference, is y over r. And hence we can actually just re-express this, okay, re-express this whole thing as x equals to r times cosine theta 1, and this is just y equals to r sine theta 1. Okay, and you realize that we can actually replace x and y of the coordinates, okay, with this amazing thing that we have here, which is x is r cosine theta 1 and r sine theta 1. Okay, so this means that the coordinates of x and y, right, is connected to the angle theta, and of course the radius. Okay, and now since the coordinates is in the positive region, right, so I'm actually referring to in fact I'm referring to this, right? So these coordinates, they are all positive, right? So this would mean that this entire thing would also be positive, right? And for it to be positive, this actually would mean one thing. Okay, this would mean that cosine theta 1 must be positive. R must always be positive, right? Because r is the distance of the length of OP. So in this case, we can conclude here that sine theta 1 must be more than 0, and cosine theta 1 must be also more than 0. Right? So this is for the first quadrant. We call this the first quadrant, right? So let's do the first quadrant. So in the first quadrant, you have a point here. The point will be positive coordinates, and hence sine theta 1 and cosine theta 1 must be more than 0. Alright, so now using this same logic, right, we're going to reflect, okay, in mathematics it's called reflecting. So we reflect the point P about the y-axis. So just imagine that I can create reflection. I hope this is more accurate. I cannot really see whether it's accurate or not, but let's just, yeah, let's do something like that. Let's make it as accurate as I can. I think should be like, okay, great. Okay, wait, I'll just delete this line. Okay, so I'm going to reflect another point, okay, and I'm going to call it Q. So if I reflect it about the y-axis, which coordinates will become negative? Okay, and in the sense, actually, my coordinates here will be negative, right? Correct? So my x coordinate will become negative, but my y coordinate will remain positive here. Now we know also that if I draw the right angle triangle here again, okay, it still has the same distance as earlier. So as you can see here, the distance here is still x, and the distance here is still y. Okay. What we're going to do is, and we know that now we want to find the angle for this point Q. We would draw the angle from here, from the x-axis on the positive x-axis, and we go anti-clockwise. So we go anti-clockwise, go this way, and to here. This is what we call theta. This is also theta, but we're going to label it with theta 2. Okay. Now we also know that we cannot actually find the sine of theta 2 that straightforwardly, right? So in this sense, theta 2 is actually connected to its basic angle here, basic angle alpha. So in fact, if I want to find cosine theta 1, I want to find cosine theta 2, or I want to find sine theta 2, I actually just need to find the sine and cosine of its basic angle, because we as we see here, we learned from we learned previously, okay, that the basic angle and theta is connected. Now for this case, it's connected by 180 degrees, and this is actually the reason why your sine of obtuse angles is formed, in fact, because in this case, if I want to figure out point Q, the coordinates of point Q, I'm going to use this guy first. So we have sine of alpha. Okay, the length here is still r. Okay, sine of alpha, this is in fact equals to y over r, and we have cosine of alpha, which is x over r. We can form the next relationship here, which is in fact y is equals to r sine alpha, and x is equals to r cosine alpha. Okay, in fact I can replace it, right? I can replace it, and if I replace x and y, okay, with the coordinates here, it will just simply become negative r cosine alpha, and this is r sine alpha. Okay, and so from here, right, we can see that remember just now we said that actually we can replace it with just r cosine theta and r sine theta, right? And we do see here that in fact, if I want to figure out the length of theta 2 in this case, it is simply just going to be the coordinate q, and the coordinate q is in fact just this over here. Wait, let me just use the yellow line. Yep, it's just this over here. And so in fact, and we learned in E-math actually that in E-math you've learned this, right? Sine of A is equals to sine of 180 minus A, and you learn that cosine of A is equals to the negative of cosine of 180 degrees minus A. And this is totally the reason why. So in this case, I can also replace all this. Negative r cosine alpha, the r doesn't really matter here, and it's just simply r cosine theta 2, and this is r sine theta 2. So I'm saying here that cosine theta 2 is equals to negative r cosine alpha. which means that your cosine value for the second quadrant, okay, so if I have a cosine value for the second quadrant, I'm going to use red here, okay, for the second quadrant over here, sine theta, or whatever it be, sine theta will always be okay, in this case sine theta 2 lah, okay, but I'm just going to use sine theta because sine theta is still just generalizing it, right? So for any angles in the second quadrant, sine theta must be more than 0, right? Because of the position of the coordinate of Q, right? The coordinate of Q, the y coordinate specifically is sine theta, and that is positive. But sine theta here must be less than 0. Okay, so that's for the second quadrant. So we have the first quadrant and the second quadrant, and you think about it, we can do this for the third and the fourth quadrant. So imagine if I do this for the third and fourth quadrant without actually doing any more proof, right? Can we actually understand? Can we actually like figure out? I'm gonna duplicate this lah. Okay. Actually, can we actually just understand where? You can just look at it again, and kind of know where is your how to say, like we can actually figure out where is what is the value of cosine theta and sine theta. Okay, so now your angle will be from here. Okay, that's a bit messy, but I'm gonna go around here, right? Then this will be theta 3. Okay, this is weird. Okay, we're just gonna do this. Okay, so this angle will be theta 3. I'm gonna erase the leftover things here. Okay, because it's not really very messy. Okay, so this is theta 3 for the third quadrant. Now with this theta 3, we can actually do the same. We actually reflected this about Q. Okay, so in fact now let's call this point R. My x coordinate is going to be negative and my y coordinate is going to be negative. So based on what we've been just doing, right? Okay, if it makes sense to you, it will show you once again that the sine sine theta value is going to be negative and your cosine theta value is going to be negative. Okay, using the same logic, okay, we're going to use the basic angle here again. Okay, so use the basic angle, just going to draw the basic angle here with orange. This is pretty long, I know, but and we do know that this distance in terms of distance wise is still y, and this horizontal distance is still x. Right, this horizontal distance is still x. So same thing, we apply the same rule. Honestly, this thing at the top still makes sense, right? So we're still going to use it here, and the basic angle doesn't change. Okay, so the basic angle really doesn't change in this sense. I'm just going to redraw everything, and because of that, we can replace the coordinate of r with whatever we have. So it will be negative of r cosine theta, r cosine alpha, and this is also negative r sine alpha. Okay, with this, okay, we can say that because the cosine alpha point, this point r, is shared with the theta 3, we can also say that for the third quadrant, only for the third quadrant, so for the third quadrant, in this case, we can form a relationship here. This is r this is r let me see, r cosine theta 3, and this is r sine theta 3. Maybe I should use green for this part, such that you kind of know what's going on here. So r cosine theta 3 and r sine theta 3 is just simply equals to negative of r cosine alpha here. So this would tell me, or this would tell us for the third quadrant. Okay, why is it negative? It's because the coordinates of both of them are in the negative region, right? The x coordinate is negative, the y coordinate is also negative. So in this case, we can safely say that sine theta for any third quadrant angle is going to be less than 0, and also for cosine theta is going to be less than 0. Now, without doing anything for the last one over here, okay, think about it. Okay, I want you all to go think about this. If I reflect this and call this a point S, and the coordinate of point S will simply be x comma negative y, which you can take a pause of this video, but which values will be positive or negative. Okay, so by the same logic in the fourth quadrant, okay, we have that sine theta will be less than 0 and cosine theta will be more than 0. So in these four quadrants, okay, we can have so many different values of sine theta and cosine theta, and if you look at it carefully, we can actually form a pattern. Okay, what we need to remember is actually a few things, but we are still lacking one thing. What we are still lacking, I should have written one here. Okay, so what we are still lacking here is, what about tangent theta? Okay, so we're going to talk about tangent theta. Now, what is tangent theta? Now, based on this relationship, tangent theta is equals to let's say theta 1 in this case, right? Okay, so let's use theta 1 here as an example. So if I want to talk about tangent theta 1, it is simply equals to the opposite divided by the adjacent, which is simply just y over x. Right, and we know that y is simply r sine theta 1, and this is, and x is r cosine theta 1. Okay, the r can cancel out with each other because r divided by r just gives you 1, and all you have left is sine theta 1 divided by cosine theta 1. And this is the relationship that you will need to remember for the rest of AMF. In fact, that tangent theta of the same angle is just simply equals to the sine theta of the same angle divided by cosine theta of the same angle. So we can actually safely say that tangent theta is simply, okay, for any angle, right, it's just simply sine theta divided by cosine theta. Okay, alright, so then what about the value? Is it positive or negative? Now, if you look at it, for the first quadrant, sine theta is positive and cosine theta is positive. So tangent theta must be more than 0 as well, right? Then we look at the second quadrant. Remember, tangent theta is equals to sine theta divided by cosine theta. So sine theta is positive, but cosine theta is negative. So tangent theta will be negative as well. Now for the third quadrant, both are negative. So if both are negative, so sine theta divided by cosine theta, this will be positive because negative divided by negative. And last but not least, over here, sine theta is less than 0 and cosine theta is more than 0, and hence we have tangent theta less than 0. So in fact, we have so much to actually remember, right? But in exam, are you going to really recall everything here? The answer is no. Okay, you don't have to. So it all boils down to this. Some people remember this by ASTC. So you just need to remember in each quadrant which are the ones that are positive. So in the first quadrant, actually every value, every trigonometry ratio of the angle in the first quadrant is going to be positive. So everything is positive. And then when you go to the second quadrant, only sine is positive, right? Cosine and tangent are going to be negative here. Okay, and then tangent theta is positive in the third quadrant. The rest are all negative. And in the fourth quadrant, if you have an angle in the fourth quadrant, cosine theta will be more than 0. So all you need to do is remember ASTC. You know, some people say it's all science teachers are crazy. All science teachers are crazy. Yeah, okay, but this is one very fast way to actually do it. So that's about it. So this is what you need to know. Okay, now how is this applicable for us? Because we need to be able to identify whether is it positive or negative. So if you look down at my example here, you have this 70 degrees and this 140 degrees, and actually you can usually draw out where the angle is. So I have a 70 degrees angle here in the first quadrant, and hence sine of 70 degrees is going to give me positive value. I have cosine 140 degrees here, okay, which is in the second quadrant, okay, and it's definitely going to give me a negative value. So that's about it for this part. Thank you.